All right, so the first thing that I want to show you is that given a perfect square, that the vertical distance and the horizontal distance along the sides of the square do not equal the distance from going diagonally across the square. So if you can see here, this arrow represents the horizontal distance across the square, right? But if I were to rotate it to make it kind of diagonal and line it up here, it doesn't reach, right? This distance across or diagonally across the square is always going to be more than the distance horizontally or vertically. Okay, so again, same distance from the vertical distance, right? But if I were to rotate it, it would not reach the other corner of the square. All right, so that is true. And for this reason, we have to, when we want to measure points on a coordinate plane that are diagonal from each other, we cannot just count bunny hops diagonally because those are not, that would not be the same distance as counting horizontally across in the x direction or vertically across in the y direction. So if we wanted to know the distance between these two yellow points on the coordinate plane, point 5, -9, and point 8, -3, we would have to create a right triangle. And then we would have to identify the legs of the right triangle. So the horizontal distance and the vertical distance. So this horizontal distance is 1, 2, 3 bunny hops for one of the legs, right? Or we know that we're going from 5 to 8 on our x axis. So that's a difference of 3. And our vertical distance is going from -9 to -3, which should be 6. So we can count our bunny hops. 1, 2, 3, 4, 5, 6 bunny hops. So that means that the distance is going, we have to use our Pythagorean theorem. A squared plus b squared equals c squared. So it's going to be 3 squared plus 6 squared will give us our total distance. So if I use our calculator, 3 squared plus 6 squared, what does that equal? Well, that equals 45, right? And then we want to find the square root of 45 as a decimal because it's asking us to round to the nearest tenth. We get 6.7 if we round to the nearest tenth. So approximately 6.7. Okay. And let's try one more example. We have these 2 points. Same idea. Because we cannot measure diagonal distance just by counting on the coordinate plane, we're going to use what we know about the horizontal distance and the vertical distance between these points to create a right triangle. And then we can use our Pythagorean theorem to identify the hypotenuse of that right triangle, which happens to be the distance between those 2 points. So again, I'm going to count my bunny hops starting at this yellow dot. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. I think I did that right. 1, 2, 3, 4, 5, 6. Yep. So both of our legs have a length of 6. So 6 squared plus 6 squared will be our hypotenuse squared. And then in order to find our hypotenuse, we just have to take the square root. So again, use our calculator. 6 squared. 6 squared plus 6. Oh my goodness. Okay, hold on. 6 squared plus 6 squared. That gives us 72. So we have to find the square root of 72. That gives us approximately 8.5. So rounded up to the nearest tenth, that would be 8.5. And there you go. How do I close this thing?